Good morning, it's Professor Shukr again, and today we are going to talk about essential concepts of research. There are certain concepts which are essential to understand, because if we understand the basics of these concepts, then we can delve into the detail of it. Now we are going to talk about IMRaD. Research as a structure program. It's a concept, meaning research is made of organized parts arranged in a logical, clear order. We must be talking about the concept of research as asking question and testing hypothesis, where a hypothesis is an educated guess or prediction that can be tested. We are going to talk about qualitative, quantitative research, variables, sampling methods, randomization, concept of basic tests, the concept of designs, the concepts of belief of the researchers on the research, and so on and so forth. Now the first is concept number one, which is research is a structured process, which is called as an IMRaD framework. That is, it's a structure, organized parts arranged in logical and clear order. IMRaD stands for I is introduction, identify the problem, establish objectives, and formulate research questions. M stands for methods, selects the design, sampling techniques, data collection methods, and analysis procedures. R stands for results, present finding without interpretation, discussion, interpret the meaning, compare with previous work, and suggest application. It is important to understand this concept of IMRaD, because many researchers see research as a structured, step-by-step process following the IMRaD format. Then second is, what is the language of research? Now, the language of research is both mathematical and non-mathematical language, meaning by research can be seen as a way to understand reality with two broad conceptions, quantitative and qualitative. The research can be a quantitative research and a qualitative research. Quantitative means, quant means numbers. So therefore, research that uses numbers, counting or measuring, that is a qualitative research. So therefore, the language which is used in quantitative research is of mathematics, numbers, formulas, and these things. Counting how many people like chocolate or ice cream is obviously a quantitative research, like measuring student exam scores to see if a study method works. Now that is also a quantitative, because score is a number, and then if you calculate mean, percentages, these all are numbers. The second is qualitative research. Qual means words and feelings. Research that uses words, opinions, or feelings to understand something. That is the language of qualitative research. Asking people why they enjoy chocolate ice creams, or interviewing students about their experiences with a new learning app. These are going to fall into qualitative research. So when researchers plan their structure, IMRaD research, they decide whether to collect quantitative data in form of numbers or qualitative data in forms of words, feelings, etc., or sometimes both, to answer their research questions. Both are valid and they address different type of researches. So first concept we discussed was IMRaD, which is a step-by-step structure which researchers tend to follow. Second, we have discovered the concept of qualitative and quantitative research, in which quantitative deals with numbers, the language is mathematical, and qualitative deals with feelings, words and sentences, and language is English language. Obviously, English is used in both. So when researchers plan research, they decide whether to collect quantitative data or qualitative data, or sometimes both, to answer their research questions. Both are valid, they address different types of questions. Another concept is Research, concept of research is asking question and testing hypothesis. Remember, hypothesis is an educated guess or prediction that you can test to determine whether your hypothesis is correct or not correct. At its core, research is about being curious, what's happening, why, how, formulating educated guess, which is a hypothesis, and then collecting evidence to test whether these guesses hold. Simple example is, does increased screen time reduces children's sleep? So therefore, if you test it, then that is, you have to formulate a guess and then continue. An example from medical college could be, do anatomy students who use 3D virtual models understand better than those who use dissecting cadavers? So form a hypothesis, assign groups, test with exams and compare the result. So our hypothesis, let us say, yes they do, assign group, one student discusses, learns on virtual models, one on dissection, then both are given the same exam, test score and compare. Summary. This conception sees research as scientific detective work. In a medical college, it's like being a junior researcher asking, if we change this in learning or practice, then what's going to happen? And then very important concept is the concept of variable. Variable in research is defined as anything in study that can change or vary. A variable is something you can measure or observe that might change in your study. The simple definition could be, it's like a factor or thing you check, change or keep the same. Depending upon that, there could be an independent variable, what you change, dependent variable, what you measure, and control variable, what you keep the same. Let's understand the example. So therefore, if you're doing research upon airplanes which your children make with papers, independent could be type of paper airplane, dependent how far it flies, and control who throws it, where you throw it from. Another example from medical college will be, independent variable could be teaching method, dependent could be exam score, and control could be same exam, same time limit. This concept sees variables as the moving pieces in your research. Another concept was sampling, and sampling is required for fair comparison. Sampling is the process of selecting a part sample from a large group of population. So therefore, the whole group is called as the population, and from what you select as the sample, so we can draw the conclusion about the whole group without studying everyone. Picking a few people or things to check instead of checking everyone, in simple words. Example is, if you want to know if apples in a basket are sweet, then in basket there are 100 apples, you taste 2 or 3 apples, and that is going to represent the taste of the whole basket. So all the apples in the basket is the population, and 3 or 4 apples, they are the sample. In medical, selecting 50 medical students from a class of 200 to study their stress levels during exam. 200 is the population and 50 medical student is going to be your sample. Then the concept of sampling methods. Using proper sampling method, which could be random, stratified, cluster, purposive, to avoid bias. Then assigning participant fairly, randomization versus non-randomization, keeping variable control. This concept views research as designing fair, balanced experiments or observations. In subsequent, we are going to understand the meaning of these words also. Now, very important concept is randomization for fair comparison. Now, randomization is a method where participants are assigned to groups, for example, control an experiment purely by chance, so that each person has an equal chance of being in any group. This helps reduce bias and make groups similar. Simply mixing people up randomly, like drawing names from a hat, like flipping a coin to decide who receives chocolate, etc. Important thing to understand is the random has different meaning in day-to-day language, whereas random is different meaning when you talk about research. For example, if I take this is the population of my instruments, and I pick something like this, it is at random. This is in everyday language because I have picked just by chance, not thinking much. But if I am doing research and I pick a thing by chance, but using a very scientific way. For example, I decide this thing, I am going to pick out of this population every fourth. 1, 2, 3, 4. 1, 2, 3, 4. Now, this is the meaning of the word of random in research. I hope you understand it. Like randomly assigning students to two groups, one using flashcard, the other using videos to compare learning outcomes. Non-random assignment is a method in which participants are allocated to groups based on non-random factors such as my personal choice, convenience, researcher's decision. This can heighten the risk of bias. Therefore, a research which is randomized is going to be definitely better than a research which is non-randomized. Okay, now we are going to talk about is study designs, analytical versus non-analytical research, descriptive versus non-descriptive research. When we talk about study designs, depending on the question, researchers choose designs like descriptive research design, what's happening, correlation research design, how are things related, experimental research design, does X causes Y, quasi-experimental, testing effects without full control, case study, deep dive into one example. Let me give you examples to understand. For example, descriptive study, just observing and describing, no intervention. For example, recording how many hours medical students sleep during exam week. So it's just observation and recording of data. In correlation study, checking if two things are linked without saying one causes the other. Now this is important. For example, seeing if there is a relationship between number of practicing MCQs and final exam scores. This is going to be correlation study. Experimental study, randomly assigning groups and testing an intervention with control over variables. For example, randomly assigning students to use a virtual anatomy lab or textbook, then comparing their test scores. Quasi-experimental study, testing an intervention but no random group assignment. For example, comparing two existing batch of students, one taught with team-based learning, which was an intervention because previously they were also studying with lectures, the other continue with lectures to see which performs better. Case study, detailed deep dive into one case or small group, often qualitative. Example, exploring how one medical student with ADHD navigates clinical rotation. It's a broad concept and later on we are going to discuss in detail also. Then there is a concept of analytic versus non-analytical research. Now, analytical research is a type of research where the researcher analyzes, evaluates and interprets existing information or data to understand relationship patterns and causes. So in analytical research, it is not simple observation, getting a data and then simply getting results from that, but thinking also about the results, how, what, why, and so on. It's like solving a puzzle by carefully looking at clues you already have. Explanation, in analytical research, you don't just collect facts, you break them down and study them deeply. You might compare groups, look for trends, or test if one thing causes another. It often uses statistical tools and logical reasoning. Obviously, example of analytical research could be comparing boys and girl test scores over 5 years to see if there is a difference. In medical college, analyzing hospital records to find if smoking is linked to heart disease. And general example could be studying past climate data to understand why temperatures are rising nowadays. Non-analytical research is research that gathers and presents facts or information without breaking it down or analyzing relationship or causes. It's like collecting stickers and showing them without trying to figure out which are rare or why you like them. Non-analytical research focuses on describing things as they are without trying to explain why and how they are related. It's often called descriptive research because it gives a picture of the situation but doesn't go deeper into analysis. Remember previously descriptive research? So descriptive research is usually a non-analytical research also. Examples are making a list of sports played in the game, reporting the numbers of dengue cases, writing a report on types of plant found in a park. Coming on descriptive, non-descriptive research. You already have an idea now. Descriptive research is a type of research that aims to describe a situation, event, or population or phenomena as it is without manipulating variables or testing relationship. It's like making a report of what you see, hear, or count, just telling what's there, not changing, not testing anything. In described research, the goal is to paint a picture of what's happening. It answers questions like what, when, where, and how much, but not why and how. It can use surveys, observations, or record facts also. Then a descriptive research example could be surveying how many students bring lunch from home, medical reporting the percentage of students using online learning tool. General example could be describing the average age and gender of the patients in the hospital. You are simply describing what you are seeing and recording it. Non-descriptive research refers to research that goes beyond describing and aims to analyze, explain, predict, and test relationship. Something is striking you. So therefore, non-descriptive research is usually analytical research. It's like asking, why is this happening? Or what will happen if I do this? Non-descriptive research includes analytical, experimental, exploratory, or explanatory students. It looks for causes, effects, predictions, relationships, etc. How and why. An example of non-descriptive research could be testing if a new teaching method improves students' math scores, studying whether a new drug reduces blood pressure, and investigation exercises reduces stress levels. These all are examples for you to understand. Then there is a concept of metric data and non-metric data. A very, very important concept. Data can be two types, metric, non-metric. Metric data, also called continuous or numerical data, data you can measure on a scale like height, weight, test, your height in centimeters, blood pressure reading, exam percentage, number of hours, etc. Whereas non-metric data, also called categorical ordinal data, data is categorized in ranks without exact measurements, like rank in a race, first, second, third, favorite color, top positions, lower 2/3, upper 1/3, Likert scales. They all fall into non-metric data. Now here today we are going to cover about parametric test and non-parametric test, then the forms, significance level, then research as construction evaluating knowledge, and research as reflection or believing and learning approaches. Now, we have talked about parametric, we have talked about metric and non-metric data. So when we have these two types of data, then that data is used to do tests. So what are those tests and what is the nomenclature? There is a parametric test. Parametric tests are usually for metric data, meaning statistical tests used when the data is metric, normally distributed, bell-shaped curve and meets certain rules. So therefore, if you've got a data which is in form of numbers and these things, and if you make a curve, then majority are falling in the middle, and then it's going to turn like a bell curve. If it is plotted like that, then the tests which are used for them are called as parametric tests. For example, comparing average scores of two math classes, using ANOVA to compare average OSCE scores across 3 teaching methods. Non-parametric tests are used for non-metric data. Statistical tests used when the data is non-metric, skewed, or when the assumption of parametric tests are not met. It means it doesn't form a bell curve. For example, comparing ranks of favorite sports using Mann-Whitney test, using Kruskal-Wallis test to compare Likert scale feedback. These are non-metric tests. Now, forms which are used is, you have numerical measurable data like marks, blood pressure, you use parametric tests. These tests are stronger if the data fits the assumption normal distribution equal variance. Example is compare average anatomy test scores across male and female students. Similarly, non-parametric forms of measurements could be rank ordered, categorical data, metric data. Compare student satisfaction level measuring on the Likert scale. Now, a very important concept is, once you get the result, then which test make the result significant? Which have more value? One is significance level p-value. P-value is equal to how sure we are that we saw didn't happen just by chance. For example, you flip a coin 10 times and get 9 heads, you wonder, is this coin fair or it's a magic coin? Our p-value helps tell you if the result is surprising or just luck. For example, if a new teaching method improves test score, a p-value helps decide if that improvement is real or is just chance. Simple rule is, if p is less than 0.05, the result is significant, unlikely to be by chance. Second is confidence interval. Confidence interval is the range where we think that true answer is with some confidence, that you have confidence it is true. You measured your jump 5 times, 150, 152, 114 and so on centimeter, you say, I'm pretty sure my average jump is between 149 and 152. For example, we say, we are 95% sure that the average anatomy test improves with flashcard is between 5 to 10%. The narrower the range, the more confidence we have. Obviously. There is effect size. Effect size means how big or important the difference or change is. You try 2 types of shoes. One makes you run 1 second faster, small effect. Another makes you run 10 seconds faster, big effect. A new drug lowers blood pressure by 2 mm, small effect, 15 mm, big effect. The rule to remember is, small p-values can be statistically cool, but big effect size tells you what it really means. Fourth is power calculation. Power, how likely your study will detect a real effect if there is one. If you flip a coin just twice, you might not notice it's a magical coin. But if you flip it 100 times, you have more power to notice something is weird. In a drug trial, testing 10 patients is low power, testing 500 patients is high power, obviously, to detect real benefit. Simple rule, more are the people involved, more are the participants, more is the power of the study and better chance to find real difference. what are the beliefs of the researcher that also affect research? For example, what is their belief about their knowledge? Now there could be a dualistic view that either the research is right or wrong. Relativistic view depends upon the situation, knowledge depends on context, the situation or setting. Constructive views, this is most important, building understanding step by step, knowledge is built by comparing evidence. Example, learning about dinosaurs by reading books, watching videos and seeing fossils, medical college. Learning about a disease by combining patient cases, textbook and research studies. Here research is seen as a dynamic evolving construction. So therefore, if a researcher has a constructive view of knowledge, his belief is of constructivist view, then he is a better researcher. Similarly, what is the learning approach? Or what is the approach of the researcher towards the research? One research could be just to record the data, and the intention of the researcher is to have a number of papers or some other thing, let's say. And the other approach of a researcher could be to delve deep into the research and find out the meanings why that is a deep approach. And you know this thing, some researchers know this thing, sometimes that research is also important in which we don't delve deeply. So they are called as the strategic researchers, and they use both optimally to find answers to the questions. Now, that's all for today's big session. These are the concepts which one must know. And I'm going to post not only this thing in the YouTube. By the way, you can join my YouTube channel Shukar Education to watch me actually teaching these same slides live as you're seeing me now. So have a good day, relax, enjoy. See you again.